Till now, we got introduced to the idea of work, energy, so on and so forth. Now, we try to relate the concept of time with the idea of work and energy. That is, we are trying to learn the concept of power. Literally, power means work divided by time or energy divided by time. The general meaning is quite simple. How fast is the work getting done? That's nothing but your power. How fast is the energy getting consumed? That's nothing but your power. Both of this relates to power. Okay guys. So let me explain this with an example that would be a lot clearer. We have person A and B. So A and B, they are doing the same amount of work. Okay. The difference being this. Person A takes just 10 minutes to finish that work, while person B finish 15 minutes. My question to you guys is, who is doing a faster work? Obviously, person A, is it not? Person A is clearly doing a faster set of work compared to person B. So he or she will have more power, right? Compared to B, that is. So basically, same amount of work with less time means more power. This is in terms of work. In terms of energy, let me give an example, right? Energy and power. So a very practical example would be this. We have a cell phone which has buttons in it. So basically this is just to receive call and make calls. While we have another phone which has all these features and apps, so on and so forth. Now, if both have the same capacity of battery, that is, the energy is limited and that limit is same in both. Which will consume faster? That is, which will drain or which will switch off faster if we continuously switch on, or if we continuously using the phone for a call, which will switch off faster? Right? Obviously, yes. Option 2. So what can we tell about power? Power consumption is more over here. Is it not? Actually, in entirety, its power consumption is more. But yeah, you guys got the idea. Power is nothing but how fast energy is getting consumed. While in terms of work, how fast the work is getting done. That's your idea of power. Now let's define power. Power is defined as rate of doing work or rate at which it transfers the energy from one form to another. Right? That's your basic definition of power. Now, in terms of formula, the same thing again and again. Power is nothing but work divided by time or energy consumption by time. Energy consumption by time. Next is unit of power. Unit of power is W, if not watt. It's supposed to be capital W. The reason being it's named after a scientist. Okay guys. Now let's define 1 watt. See, 1 watt would be nothing but something divided by something. What should that something be? The best possible number is 1 by 1. In the numerator we have work, so the unit of work is joule. In the denominator we have time. It should be in seconds, right? And now let's define. We can define it in 2 ways, in terms of work or energy consumption. Right? Energy generation and energy consumption. Actually, it's not only consumption, it can be generation also. Now, in terms of work is what we said to have been doing 1 joule of work if we consume 1 joule of energy in 1 second. Or if we spend 1 joule of energy in 1 second. Your language can vary. Energy, in terms of energy, we said to generate 1 watt of energy if we generate 1 joule of energy in 1 second. Again, we said to have been generating 1 watt of power if we generate 1 joule of energy in 1 second. So there are many ways of defining it. So this is one of the ways. 1 watt is the power when 1 joule of work is done in 1 second. Very simple and straightforward. Okay guys, I want you guys to get used to the idea of work and energy being related to power, right, in terms of time. Is it not? It's quite simple. Now, sometimes you get to find the average power. How do you do that? Well, if you have power that is not stagnant, it keeps varying. That's what happens in phone, right? If you are on a call, what happens? So if you're on a call, the power consumption is more, and if you switch it off and all of that, there's some power consumption. If you switch on the app and things like that, it might be even a lot more, and so on and so forth. Is it not? So power consumption keeps varying. All you have to do is find the entire power consumption throughout the time period. Okay, find this area basically. That would be your entire energy consumption. Since we know the entire energy consumption, just divide that with time and you're done. So the average power is nothing but total energy consumed. That is the area over here. So total energy consumed in entirety divided by time. Okay guys, so that's your basic idea. So if they give you graph and all that, area under power versus time graph divided by time. So that's your answer. So now pause and have a look at all of this.